I wonder if we could just touch on whole house ventilation, Greg. There's a really good question there about ERVs and alternatives to that.
Yes, yeah, and I did want to get into that, and we haven't got a lot more time left. So, but yeah, Mark, the ventilation in our houses is something that we don't really think of much. In our building code, it's basically open a window.
Yeah.
But when when we're doing a higher performance house with our water, air, vapor, thermal layers, all controlled well to a good air tightness strategy, can you talk us through the strategy of how we do a whole house ventilation system, or what is important?
Yeah, you know, it's a great question, Greg. You know, if you look at, here's the strategy we often hear. Somebody will say, so you're going to tell me to build an airtight house and then you want me to put a ventilation system in? What's wrong with you? You know, why don't I open the window or punch some holes in the wall? And you're like, okay. Remember, what we're trying to do is to control. So if I open windows, an open window is a good strategy. It provides ventilation. It doesn't provide me any control. I don't know, when am I going to open the window? On windy days, on dusty days? What about rainy days and foggy and cloudy days, or if there's a temperature inversion? What about those days? Well, no, I'm not going to open the windows on those days. So that would be called intermittent ventilation. So I don't know if you're able to interrupt your breathing rate to affect the outdoor conditions, but that's what sounds so stupid, right? The outdoor conditions are bad, the pollens are high. Today I'm going to hold my breath because otherwise I'm going to have some allergies. The idea is that you build a building so that it can mimic and introduce ventilation at the rate I breathe. If you want to open the windows on a beautiful today, right now in my house, I have the windows open. It's beautiful. It's 60 degrees outside. It's gorgeous day to ventilate. But tonight it's going to get down to 45 degrees. I'm going to close the window. Now my house has a continuous level of ventilation and it runs all the time and uses a small amount of energy. I know that whether I have my windows open or closed, my building is continuously ventilated. In the summer, it's 100 degrees Fahrenheit here. I've got my ventilation system bringing in just as much as fresh air as I need for respiration. I breathe about 9,000 liters of air a day. I want to make sure that because it's uncontrolled, I have no way of interrupting my breathing cycle. So I would like my ventilation to represent my respiration cycle. So the strategy here is build a tight building, provide continuous ventilation. The ways to do that are basically three. Exhaust-only ventilation. If I put a fan in the house, a very good quality Panasonic or Braun fan uses 20 watts of electricity. It's insignificant. They cost $150 US. So if I put that in the ceiling, I turned it on and ventilated it out. As I'm running that fan somewhere, somehow in the building, it can't leave if it can't come in. It has to come from outside or potentially from under the slab. So let's say I got a fan and I'm going to bring air in and blow it out the ceiling. I'm going to blow out the energy, but I'm going to replace it with outdoor air. I don't know where it's coming from. Could be where the dog kennel sits or could be near the garage, but I don't have any control. Another approach, which we see here in the South, is to use what's called supply side ventilation. I'm going to take a fan, I'm going to turn it the other way. I'm going to go and find a good location with fresh air, and I'm going to blow fresh air in the house. And blowing it in the house, it's going to start to blow the house up, right? So now the air's got to get out. It's going to leave through cracks and seams, but at least I'm introducing fresh air. I could then control that by filtering it as well. So let's say I've got a quiet fan, a filter, and I blow it to the inside of the house. Would that be considered ventilation? I'd say, yeah, as long as I controlled the outdoor air, brought it in, filtered it, and delivered it on a constant basis, that would be a controlled way of ventilating a building, a low cost way of ventilating a building. Now, the last one would be balanced or energy recovery ventilation. Now, I got involved in energy recovery ventilation in about 1986. And the ideas were that we can take and ventilate a building, exhausting air out and introducing air in at the exact same rate using one motor operating two pulls from outside. One blew air out, one brought air in. In doing that, I could recover both the energy, so the heated energy goes into the cooled energy in whichever direction, whether it's outdoor, it's cool, and coming in, the heat from the house is able to warm the fresh air coming in. In the summer, it's reduced. The hot outdoor air is cooled by the air that's exhausting from the air-conditioned space. So that's an energy recovery component. The ERV part is moisture. And that's an enthalpy control. What it allows me to do is, in the wintertime, I'm not sure, but do you guys get cold? I mean, do you guys get dry inside the houses? Yeah, I would say that because the ERV recovers about 40% of the moisture that would normally be exhausted outside, a normal house with some baseline ventilation, we find that in almost every climate zone, from Minnesota in the north to Arizona in the south, an ERV works in all of those climates well to kind of manage and balance humidity. I would like to have 40%, 45% relative humidity in my space. That's good for my lungs, good for my wood furniture in the building, good for the wood flooring, the cabinets. They would like to be in that moisture range. If you ventilate a house with an HRV, all you're doing is you're going to eventually dilute the moisture levels down that you're producing to a level that now it is probably too dry. And we found that out oftentimes in cold climates. People were ventilating in cold climates. The houses got so dry, they shut off the ventilation systems. So now what we do is use ERVs to recover some of that moisture. And in the summertime, it rejects some of the humidity that would come in and challenge my air conditioner's ability to dehumidify.
Okay. Okay. That's good. So really what we have here with our situation is we don't have a lot of ERV or even HRV systems on the market, and the ones that are quite expensive.
Yeah.
So our starting point that I've been dealing with is basically an exhaust only fan, like a Panasonic fan, that works.
Sure does.
And until we get, and also that works around 3 air changes per hour. When we're doing a house here, that's achievable with our construction methods without going too far from standard, without going down the passive house route of, changing the assembly. So around 3, we can get there, and with an exhaust only fan, we're still okay. Once we get below 3 though, we're really heading into something where we need a balanced air system. And I suppose one of the challenges and the tricks we have here is to advise people on what to do within the current construction methodology without overloading the price, but by providing a good result.
Yep, and I think that you'll watch. It always takes this, as we know, supply and demand is the way the world of economics works. As you look at ERVs and HRVs here in this country, we see some of them run between $500 and $1,000 for the unit. You guys probably pay a lot more for that just because someone's taking advantage of you. But I would say that there's a lot of opportunities, even if it's $1,000, fairly small amount of cost to provide healthy air for my buildings. Am I willing to invest in my air quality for my family? And does that matter to me? I think it's probably one of the most critical things. I've been involved in ventilation my entire life, Greg. You said just recently is one of the places I cut my teeth on. I spend most of my time nowadays looking at the idea that ventilation, since COVID, it was a part of the strategy. 2 weeks ago, I was in a restaurant in the California coast, and they've decided that increasing the ventilation rate and providing filtration allowed the building to get so that it managed its energy flow, but had the same air quality as being outside on the patio and living outdoors. So ventilation is critical. How you achieve it also matters. You said that exhaust-only ventilation can work in most cases. I would agree that that's true, except always remember something. When you go to exhaust-only ventilation, you do not know where the air is coming back in. So we call that the origination of air. When I depressurize the building, I'd say, where did it come from? You're like, around. I'm like, I don't know. Could it come in from a garage? Could it come in through a flue? Could it come in through an area near where the garbage cans are stored? I have no control. So unless you intentionally know where the air is coming in. So the Europeans created some diffusers, and there's a little pop vent. And what you would do is you would pull the little cord, you would pop the little vent out and provide a controlled leak. You'd have an exhaust fan someplace else, a controlled leak, which would bring fresh air in and say, I know it's coming in from there, not from some unknown source. Otherwise, we turn the fan around and push the fresh air into the house. And in many climates, that works effectively to now let at least I know the fresh air is coming in and it's going to leak out of the building. As long as it's fairly well managed, that works. But I don't think there's really a magic number. I think I would want balanced ventilation at 3, at 2, at 1, at 0.6. I like balanced ventilation because I know where it comes in. I want to filter it so that I reduce pollens and dirt. I want to know it's going back outside, and I want to know where it goes. So if I really want control, and I think that's what people want. If you're driving in your car, you wouldn't believe how airtight your car is. I've got filtration in my car. I've got controls. I can dial it up 71, 72, 70, pick the temperature. The way you control an interior environment that you're going to live in for your life is to make it airtight, properly ventilated and conditioned. And then you'll have a much safer, healthier, and more enjoyable space to be in.
Yep. So, and a lot of this is educating people, the designers, the building surveyors, the builders on how to do this. A lot of the time, we see designs with cavity sliding doors or pocket doors, as you would call them, between the garage and the house. If you're making everything else airtight, then you're just asking for trouble there. So there's this level of understanding. We need to really know not just how to do it, but why we're doing it, and then implement everything as a system to make it work properly.
I was just asking about blower door tests, and that's just a way of quantifying the airtightness, isn't it?
Exactly, Darren. That's a great question. Blower doors have been around. I saw my first blower door in 1983, and we were using those in retrofit buildings. And so we would install the blower door in the front. It's pretty crude, but we would depressurize the house, and then we would see what CFM at 50 pascals, how many cubic feet per minute we would be able to pull through. And of course, the numbers were fairly high. People would go around in the attic and around the house and start caulking things. And when we reached 1500 CFM exhaust, everybody would yell, stop. We'd shut the blower door off and turn off the caulking assembly and see that we kind of got it pretty tight. That was the strategy in 1983. The idea was that a blower door is going to help me normalize the fact that I need to know how big the hole is. And that's basically all a blower door does. It says, is the hole this big or is it this big? I need to know, because I can't size a heating system, a cooling system, or as Greg alluded to, a ventilation system, and unless I know how big the hole is. If I then have the size of the hole, if leakage and infiltration represents about 30 to 40% of the energy loss in the building, why would I not want to know that? How do I size a heating and cooling system if I have no idea where 30% of the energy flow is going? I'm going to guess high. If I want to right size equipment, I'm going to use the blower door to depressurize the house, find out how much air is leaking in, give that information to my heating contractor. So he goes, based on the insulating value of the wall and the air tightness of the building and the performance of your windows, you need a 2-ton air conditioner. I was going to put in a 5. You don't need it because I did the math. The math is air leakage, thermal integrity in the building, and solar performance on the windows. That's how you size heating and cooling. So if you really want to control your indoor environment, you have to do those things, and then a blower door test validates that. Our code will require every house in the US will have to have a blower door. That will be the code of current status.
Yep.